Chapter 7 Review Part 5. Bet you're having fun now. Hyperbolas, last sort of graph we've got to look at. And what's the basic shape of a hyperbola? Well, they're the really tricky ones that come up when I have y equals 1 over x. Well, that's my basic shape. I could make it a over x, but the shape really would stay the same. What happens is I get that pretty cool looking shape. Why is it that shape? Well, if you imagine x getting really big, then 1 divided by a massively big number is getting really close to 0 over here. That's why that's an asymptote. As x gets really big, asymptote, there's an arrow on the x-axis there. Arrow on my y-axis, should actually label those always. You can see here, as x gets really big, this graph's going to get closer and closer to a y value of 0, because 1 divided by a huge number is basically 0. If x becomes a fraction, like 1 divided by half, then I start getting to 2. 1 divided by 100, it'd be 1 divided by 1/100th would end up being 100. So it starts getting really big very quickly as x gets closer to 0 from the right. The problem is, and the reason why division by 0 is undefined, is because if I approach from a negative side, if x was negative 1/100th, 1 divided by negative 1/100th would be negative 100. So we have here a function that's approaching positive infinity from the right, but negative infinity as we're coming from the left. They're not going to the same value. So when we divide by 0, we can't find a solution. Hence the reason we call it undefined. What's happening out here on the left? Well, if you imagine a really big negative number, 1 divided by a massive negative number would be very tiny, be close to 0, but it would indeed be negative, and that's why it's getting closer to that axis from below. So, two asymptotes, vertical and horizontal. All we do then is shift the graph around, but there's not much else to it. Let's have a look at a couple of examples from the chapter review and you'll see exactly what I mean. Sketch these hyperbolas, labeling the points where x equals 1 and x equals negative 1. Well, let's do the first one. So the first thing you'll notice is I haven't added or subtracted anything, which means there's been no translation, and my asymptotes are going to be in exactly the same spot as they usually are, which is the y-axis and the x-axis. Now, if I was sketching this in an exam, yes, you put in your asymptotes, label them, and then all you have to do is draw the general shape. Don't worry about labeling any points yet. We know the general shape is going to look nothing like that. That was just a bad drawing. Let's try and get it a bit closer. Looks something like that. And something like that. And then all we have to do is label the points. So when x equals 1, 2 divided by 1 would be 2. So when x equals 1, y would equal 2. And that would give me the point there of 1, 2. So what's happened in this one? The 2 has just stretched my graph a little bit vertically that way. So it's a little bit more stretched out than it usually would be. But otherwise it's exactly the same. Now, because we're not brilliant at estimating how quickly these things are, when it says sketch, if you get the general shape right and label that point, you'll be given all the marks. Same here when x is negative 1. Oh, negative 1 looks more like about there. Negative 1. Y is going to be 2 divided by negative 1, negative 2. So that's going to be the point negative 1, negative 2. And that's it. The only other thing you could do is label the equation, y equals 2 over x. And we've got it. We've got our asymptotes in there, the dotted lines. We've got our general shape. We're done. What's different with this one over here? Negative 3 over x. What does multiplying the right-hand side by a negative do? That's right, it reflects it in the x-axis. Now, let's see if we can just draw this one by freehand. It doesn't really matter. If I reflect in the x-axis, this right-hand portion here is going to be reflected down to here. This left-hand portion here is going to be reflected like that. And this time, instead of being stretched by a factor of 2, it's been stretched by a factor of 3, so it's a little bit further away. So when x equals 1, y is going to equal, in this case, negative 3, because it's been reflected. Don't know why it wants to do that, just doesn't like it. So that's going to be 1, negative 3, and over here, when x is negative 1, negative 3 divided by negative 1 will be positive 3. And that would just be the point negative 1, 3. And that's it, you're done. You substitute it in two numbers to get some simple points, And you knew the general shape, because multiplying by a negative turns it upside down. It's not that bad, is it? Let's have a look at one more, maybe slightly more interesting one. We're going to look at this again in the next video and last video for the chapter, where I just talk about the transformations in general, but we might as well just have a sneak preview now of, here we go, y equals 1 over x plus 2 minus 3. So what are the transformation that's happened? Subtracting 3 means it's moved down 3 units. That means my asymptote that's usually horizontal at the x-axis, that moves down 3 units as well. So for HA, my horizontal asymptote is now going to be y equals negative 3. And you can see that that makes sense. This function can never equal negative 3. It must be an asymptote because that fraction can't equal 0. The only way a fraction can equal 0 is if the numerator is 0. That numerator is not 0, so it will always have some value. So the whole function could therefore never equal negative 3. Now we talked just a second ago about not being able to divide by 0. This one's going to have a vertical asymptote when the bottom equals 0. The other way to think about it, adding 2 to x shifts it 2 to the left. So the vertical asymptote is going to be 2 to the left. It's going to be where x equals negative 2. Can you see if I substitute in negative 2, I would have 1 divided by 0, undefined. Therefore, there's an asymptote there. So when I go to sketch these, I don't need to think too hard about it. I just go, okay, here are my axes. All I really need to do is plot in these asymptotes, negative 3, y equals negative 3, x equals negative 2. So that's taken about 2 seconds of thought to get those. I haven't really had to do anything. Label them. X equals negative 2. We've already labelled y equals negative 3. And then I just go with the general shape that we usually have gone with. It hasn't been turned upside down because I haven't multiplied by a negative. So this one's going to look something like that. And this one's going to look something like that. Now I may want to check these intercepts just to make sure I got them in the right place. That one looks a little bit like it's going through the origin. If I wanted to check that first, when x equals 0, y is going to equal 1 over 2 minus 3. Y is actually going to equal negative 2.5. So you can see I've drawn that a little bit high. So maybe I could just adjust my sights a little bit and have it going through like that. I somehow deleted the y-axis. There it is. Put it back in. Label that x-axis too. And now I could label that intercept if I wanted. I'll use a black pen to indicate that it's for that one. That's y equals negative 2.5 or negative 5 over 2. If I wanted to find the other intercept, I could. Seeing as though this is getting close to our last video, why don't we actually go ahead and do it? When y equals 0, I'm going to have 0 equals 1 over x plus 2, take 3, add 3 to each side, I get 3 equals 1 over x plus 2, multiply through by x plus 2, and I've got 3 times x plus 2 equals 1, 3x plus 2, 3x plus 6, use my distributive law correctly. Nearly caught myself out there. That's outrageous. There we go. 3x equals negative 5. X equals negative 5 over 3. And you could find that intercept too if you really wanted to. Negative 1 2/3, negative 5 over 3. Right there. There's my origin. And I'm done. So really all you have to remember is shifting left and right. That's what I'm doing in the last video, just as a reminder. Hopefully that helps you out with these. They're really not very hard. Sketch the asymptotes, general shape, done. That's all there is. See you in the last video. Cheers.